Assalamu alaikum warahmatullahi wabarakatuh. I'm going to present the introduction and problem statement of our assignment. First of all, we have the introduction. This assignment is related to application of second order differential equation in electrical circuits, in particular the RLC circuit. So first, you must know what are second order differential equation and what are RLC circuits. First, the definition of second order differential equations. Second order differential equation contains a second order derivative but no derivative higher than second order. And there are two types of it, homogeneous equation and non-homogeneous equations. Second definition of RLC circuits. RLC circuit is an electrical circuit containing resistor, inductor, and capacitor connected in series or in parallel. The name of the circuit is derived from the letters that are used to denote the constituent components of these circuits, where the sequence of these components may vary from RLC. The RLC circuit is representative of real-life circuits, as we can actually build since every real circuit has some finite resistance. RLC circuits have many applications as oscillator circuits, radio receivers, and television sets. But our main focus and the most important application is in second-order differential equations, where any voltage or current in the circuit can be described by a second-order differential equation in circuit analysis as shown later in the manual calculations. The three circuit elements RLC can be combined in a number of different topologies. All three elements in series or all three elements in parallel are the simplest in concept and the most straightforward to analyze. Then we have the problem statement. So this is a question for the assignment, which of course related to second order RLC circuits. Here we given the value of resistors, inductors, and capacitor, and we also given some initial condition to find the constant in the problem. So this problem will be solved by applying the homogeneous and the method of undetermined coefficient as shown in the calculation, which is involved in the second order differential equation techniques. And by also rearranging the equation and then applying the initial condition to find the constant in the problem and substituting into the equations to find Q and I in the circuits. So that's all from me. Thank you.
In this assignment, problems related to RLC circuits require equations that can be formed using second-order differentiation. This equation is used to determine the different values in the RLC circuit. By using Kirchhoff's second law, the equation below can be made. With the given values and conditions, the value limit of Q and I when t approaches infinity can be determined using the second equation listed here.
Assalamu alaikum. My name is Tahir Sharif. I'm going to present the manual calculations. First of all, the differential equation according to Kirchhoff's second law, which is L d squared q over dt squared plus R dq over dt plus q over c equals to et. And this is the general equation. Based on given information stated in the problem, the differential equation becomes d squared q over dt squared plus R over L times dq over dt plus 1 over LC times Q equals to ET over L. And then we change the equation into homogeneous equation. D squared Q over dt squared plus R over L times dq over dt plus 1 over LC times Q equals 0. And then we transform it into characteristic equation, which is m squared plus 400m plus 200,000 Q equals 0. Then find the roots using characteristic equation through quadratic formula, which is m equals to negative b plus or minus square root b squared minus 4ac over 2a. And this is the general equation. The case when roots are complex, m equals to alpha plus or minus I beta. And then after finding the roots of this equation, so the general equation using the method of undetermined coefficients will be Q equal E power alpha t, A cosine beta t plus B sine beta t, where A and B are constant. So I equals to dq over dt equals to alpha E power alpha t between brackets negative a plus 2b cosine beta t plus negative b minus 2a sine beta t. The equation 1 and 2 describe the charge and current at time t, given in the initial condition q equals 0 when t equals 0, and then we substitute these two values into equation 2 in order to get the value of A. And then, given the condition I equals 0 and t equals 0, we substitute these two values plus the value of A into equation 3 to get the value of B. Therefore, Q equal negative E alpha t between brackets A cosine beta t minus B sine beta t. And I is equals to BE minus power minus alpha t sine beta t. And this is the general equation. This was the solution steps of A. As for B, we will repeat the same steps. This is the question, and this is the solution. I'm going to start with A, and I'm going to solve A first. This is the given information. R equals to 20 ohms, and L equals to 0.05 Henry. C equals to 10 power negative 4, and ET equals to 100 volts. The initial condition is Q equals 0, I equals 0, and T equals 0. The differential equation according to Kirchhoff's second law, L d squared Q over dt squared plus R dQ over dt plus Q over C equals to ET. Based on above given information, the differential equation becomes dt squared d squared 2q over dt squared plus 20 over 0.05 dq over dt plus 1 over 0.05 times 10 power negative 4 times q equals to 100 over 0.05. And then d squared dq over dt squared plus 400 dq over dt plus 200,000 q equal 2000. This is non-homogeneous equation because f of x is not equals to 0. And then we change the equation into homogeneous equation. The homogeneous equation corresponding to above equation at the characteristic equation. d squared dq over dt squared plus 400 dq over dt plus 200,000 q equals 0. And then we transform it into characteristic equation, which is m squared plus 400m plus 200,000 q equals 0. Then find the roots using characteristic equation through quadratic formula, which is m equals to negative 400 plus or minus square root 400 squared minus 4 times 1 times 200,000 over 2 times 1 equals to negative 200 plus or minus 400i. The case when roots are complex, m equals alpha plus or minus I beta. After finding the roots of this equation, so the general equation using the method of undetermined coefficients will be q equals to e power minus 200t a cosine 400t plus beta sine 400t plus 0.01, where a and b are constant. So I is equals to dq over dt equals to 200e power 200t between brackets negative a plus 2b cosine 400t plus between brackets negative b minus 2a sine 400t. The equation 1 and 2 describe the charge and current at time t, given the initial condition q equals 0 and t equals 0, and then we substitute these two values into equation 2 to get the value of a. So a is equal to negative 0.01. And then given the condition I is equal to 0 when t is equal to 0, So we substitute these two values plus the value of A equals to negative 0.01 into equation 3 to get the value of B. So B is equal to negative 0.005. Therefore, Q is equals to negative E power negative 200t between brackets 0.1 cosine 400t negative 0.005 sine 400t plus 0.01, and I is equals to 5e power negative 200t sine 400t, and this is the general equation of I. And then note that this is when t approaches infinity. And then we are going to solve B by given information. R is equals to 20 ohms, L is equals to 0.05 Henry, and C is equals to 10 power negative 4, and then we change ET to equals to 100 cosine 200t. The differential equation will be d squared q over dt squared plus 400 dq over dt plus 200,000 q equals to 2000 cosine 200t. Using undetermined coefficient method, so q is equals to e power negative 200t between brackets a cosine 400t plus b sine 400t plus 0.01 cosine 200t plus 0.005 sine 200t. And this is the equation 2, where a and b are constant. So this is the equation of I. Equation 2 and 3 describe the charge and the electrical current at time t, and substitute the initial condition t equals 0 and q equals 0 into equation 2 to get the value of a, which is going to be negative 0.01. And then substitute the initial condition t equals 0 and I equals 0 and a equal negative 0.01 into equation 3 to get the value of b, which is going to be negative 0.0075. Therefore, these are the equations of q and I when t approaches infinity. And finally, q is equals to 0.01 cosine 200t plus 0.005 sine 200t, and I is equals to cosine 200t negative 2 sine 200t. This solution is known as a steady solution. Thank you.
From what we can conclude, the equation that has been given is second order RLC circuit. This is because we can identify that the circuit have a resistor, conductor and inductor connected in series. So to solve the equation, we use the RLC circuit differential equation, which is L d square q over dt square plus R dq over dt plus qc equals to E in terms of t. After that, we use a quadratic equation, which is m1 m2 equals to negative b plus minus square root b square minus 4ac equals to 2a to determine the type of the non-homogeneous equation. Finally, we get the non-homogeneous equation to solve the equation, which is q equals to e power of alpha t in the bracket a cos beta t minus b sin beta t. From that equation, we get the q and I value after we insert all the value that have been given. Appendix. Here's the equation that we use to solve this question. Number 1 is RLC circuit differential equation, which is L d square q over dt square plus R dq over dt plus q over c equals to E in term of t. Number 2 is quadratic equation, which is m1 m2 equals to negative b plus minus square root b square minus 4ac over 2a. Number 3 is non-homogeneous equation, which is q equals to e power of alpha t in the bracket a cos beta t minus b sin beta t.